Okay, this first part, I'm going to go through the Unit 4 assessment, and it's Form 18A. It was the white copies. I'm going to go through this, but the first time I'm going to go through this is simply writing down the flashcard or the process I need to solve each problem. So, first of all, first and foremost, you should have gone through your assessment and flashcarded by yourself. So this is for videos for you who need to check your answers and to figure out the ones that you didn't know what the flashcards were for. So the first question is a related rate question, and we define it for you. It's a rate question because it has a rate. What are your steps, or what is your flashcard for related rates? See how it's all rates? Rate, rate, rate. Step one, write rate equation. And we'll go through this particular question on the second video. Second thing is DDT it. Take the derivative so it is a rate. 3. The key thing with 2 we note constants, or I guess what we said is variables are stay variables. In other words, if they change over time, then you have to leave the variable, even though they may not give you a number at an instant. So just don't change it. Step 3 is to use information or the numbers they give you. And 4, solve. So using your information, sometimes you have to find the information based on what they give you, and we'll look at specific examples. So that is your flashcard that needs to be copied for all of the 3 related questions. Even though you didn't do it, you need to do it for all 3. Optimizations. These are all optimizations. You know that specifically by the words. Like, for example, this one says nearest. So that means you need steps. Step 1, you need your opt equation. So what are you trying to find? What are you trying to maximize or minimize? There should be an equation for it. 2, make equation single variable. 3, take the derivative. dd, whatever the variable is, x or y or q, whatever the variable has. This is not a related rate. So should be no respect because the equation is with one variable. So you don't have to worry about respect there. 4, well, 4 is, well, maximize steps or optimization or your uh, find your relative extreme steps, which are step 1, crits. That's when you set the derivative equal to 0. 2, intervals or ends. Now, most of these optimization questions are applied, so you don't need that. Step 3, intervals. But again, here they're applied. Generally, you're going to get one value for a crit point that's usable in the equation, so you may not even have to do that. And step 4 would be y values, but it kind of ties in with our next step overall. Your 5th step to an optimization question is 5 is answer the daggone question. Because you may be getting an x, but they're asking for the y, or they're asking for the distance, or they're asking for the area, or they're asking for something. So those are your flashcards for the next 3 questions, because all of those were optimization questions. Here at number 7, words tell you what to do. Linearization. Well, That's writing the equation of a tan line. That's what I'm thinking. And then you use it. So step by step, 1, find the derivative. 2, find your slope. 3, you need a point. 4, write equation. And your equation is a line, so y equals mx minus x1 plus y1. And the x1 and y1 are your point, m is your slope. And the last thing is 5, use it. In other words, plug in the x they give you and use it. Okay, here we didn't have to do that last step because they're not asking for you to actually use it. They're just asking you to find the linearization. That means just find the line. 8, keyword, relative max. What are your steps for relative extremes? Step 1, crits. That's where the derivatives equal 0. 2, ends. 3, intervals. 4, y values. Now, if you think about the process, you'll realize that you got something unique right there when you do number 1. I'm going to emphasize that a lot of you have issues with actually taking the derivative of these fraction things. You'll see that in the next video. This one, okay, again, I don't see particular words, but yes, I do. I see increase, decrease. Well, what's your flashcard? For increase, your derivative must be positive. For decrease, your derivative must be negative. That's your flashcard. And there are always intervals of increase and intervals of decrease. So pretty much your steps, step 1, find the derivative, set equals 0, or basically that's finding your crits. Step 2, ends if they exist. 3, intervals. Here is where you get that information. Next one, keyword, point of inflection. Again, you can't do this problem if you don't know what that is. Okay, end of the conversation. By definition, a point of inflect is where concavity changes. So steps, 1, set your double derivative equal to 0. Step 2, do intervals and check for change in sign. That means you want to see it's changing from a positive negative or negative to positive. But if you get a negative negative interval, then it's not a point of inflection in between. Okay, number 11. Again, refer back. We did the linearization one. Write down your steps. All right. So most had weakness in graphs. But without information or knowing what that means, your flashcards, you're kind of done. When I say the derivative is greater than 0, that's telling me when is the function increasing. Flashcard for this piece is, well, if the double derivative is less than 0, that means it's concave down. If you don't know those two things, this question doesn't make sense to you. And as I go through the problems, you're going to emphasize this is actually the function. It's actually the picture of the graph. It's not the derivative. It's not the double derivative. Okay? So we're just actually looking for terms there. Again, changes in concavity. That's basically your steps for point of inflection. So what do you need? You need the double derivative and then follow your process. Make sure you see change in concavity. We already did point of inflection flashcard. That's the same one you write for this one. Okay, now the difficulty here is people have a difficult time with understanding that's not the function, that's the derivative function. Doesn't change your flashcard at all. Okay, flashcard for this one, functions decreasing. That's where the derivative is negative. You're not looking at that graph for the slopes being negative. You're looking for this thing being negative. Okay, we'll get to that when we do the problems. Find the max of the function. What are our steps for extremes? 1, crits. 2, ends. 3, intervals. 4, y's if you need them. And as you can see in this problem, they don't ask for y's. They just want the x's. And yes, you can do it the same way, but that's the derivative. They're giving you the derivative function. Here's the point of inflection. This is the third time, same flashcard. Write down the steps for point of inflection. Remember, the definition of point of inflection is where the concavity changes. So set the double derivative equals 0, do your intervals, and make sure those intervals change sign. This has two things. It says increase, which means they're looking for where the derivative is not negative, where the derivative is positive, and concave down means they're looking for where the derivative, double derivative, is negative. Now again, this is referring to a graph, so 2 key points is if I give you the graph of the derivative, if that's what I'm giving you, okay, I give you the graph of the derivative, then that means when I'm looking for the f-tick, I'm looking at points on the curve, not slopes. If I'm looking for the double derivative, that implies I'm looking at the slope on the graph of the derivative. So this is the graph of the derivative, so I'm looking for slopes there. Okay, that is your flashcard recall for the whole test. The second video will go through the test itself. Remember, you're writing the flashcard items on the left, and you're going to do the work on the right. Hopefully, as you sit there and look at your flashcard, you'll be able to perform much better with those items. Okay, see you on the flip side. See you on the second video.